Hi, in this video we're going to learn how to do multi-step equation reaction problems. You're going to still need your piece of paper, a calculator and your periodic table. As you watch the video, again you're going to be asked to stop, do a step, do this and then continue. If you don't understand a step, go back, rewind, if necessary, rewind and watch the whole thing. Many chemicals are made by a sequence of reactions, each with their own equation and efficiencies. Efficiencies are like a yield. So in equation number 1, down the bottom here, you can see that sulfur plus oxygen making sulfur dioxide is 100% efficient. That means that 100% of the sulfur is going to be turned into sulfur dioxide. The second equation is only 80% efficient. That means out of the sulfur dioxide, only 80% of it will be turned into sulfur trioxide. The other 20% is just wasted, not used, doesn't react. So we have here a sequence of reactions for making sulfuric acid from sulfur. Using this sequence of equations, what we're going to do is we're going to start with a mass of product, and we have to calculate the mass and moles of the, we're going to start with the mass of the reactant, and we're going to work out the mass and moles of the product. So we have 128.2 grams of sulfur, which was our initial reactant. What I need you to do is to change this into moles. So very quickly, pause and do this. So working out your number of moles of sulfur, it's going to be 128.2 divided by the molar mass of sulfur, which is 32 approximately. So we get 4 moles of sulfur. We can now go to our sequence of equations. If you go back to your equations, you have sulfur is going to become sulfur dioxide, and then sulfur dioxide became sulfur trioxide, and then sulfur trioxide becomes sulfuric acid. So if I had started with 1 mole of sulfur, my equation tells me that I would make 1 mole of sulfur dioxide. So I assume I finished this reaction with 1 mole of sulfur dioxide. And now I start my second equation. If I start this with 1 mole of sulfur dioxide, I should make 1 mole of sulfur trioxide. I know there are 2's here, but these 2's just represent the mole ratio of sulfur dioxide to sulfur trioxide in this equation. I started with 1 mole of sulfur dioxide, so I'm going to make 1 mole of sulfur trioxide. I carry that 1 mole down into my third equation, so 1 mole of sulfur trioxide will make 1 mole of sulfuric acid, which gives us the mole ratio between each of the 4 chemicals: our starting reactant, our second reactant, our third reactant, and our product. And the mole ratio was 1 to 1 to 1, but in this question we started with 4 moles, so it will be 4 moles of sulfur will make 4 moles of sulfuric acid. Okay, so looking at our equations again, you'll see at the end of the line each one has its own efficiency. So we are trying to now work out the number of moles of sulfuric acid using these efficiencies. This 4 moles that we worked out was only the number of moles that we could make if all of our reactions were 100% efficient. So 4 moles of sulfur could be turned into 4 moles of sulfuric acid if we had 100% efficiency, but we don't have that in all 3 reactions. So 4 moles of sulfuric acid we now multiply by the efficiency of the first equation, which is 100%. So we're going to multiply that by 100 over 100. The second equation is only 80% efficient. So only 80% of our reactant is going to turn into our product. So we multiply that by 80%. And then our third reaction is only 20% efficient, so we multiply that by 20%. So in theory, we should have 4 moles of sulfuric acid being made, but because of our efficiencies or our inefficiencies, we only end up making 0.65 moles of sulfuric acid. So we have just worked out that we have 0.65 moles of sulfuric acid being made. We should now be able to stop and turn those moles of sulfuric acid, 0.65, into a mass. So press pause, do that quick little calculation. Okay, so we had 0.65, we multiplied by the molar mass of sulfuric acid, so we made 63.8 grams of sulfuric acid, taking into account the efficiencies of the reactions. So in this sort of question, we've gone from the mass of the reactant to working out the mass of the product. The other type of reaction is we start with the product and we have to calculate how much reactant was needed. So from that same sequence of equations, what mass of sulfur is going to need to be burnt, so this is our reactant, to produce 196 grams of sulfuric acid. So again, as always, our first step in a chemistry calculation is try to change things into moles. So turn 196 grams of sulfuric acid into moles. I once told a chemistry joke, but there was no reaction. So back to our question. We were changing 196 grams of sulfuric acid into moles. So 196 divided by 98, we get 2 moles of sulfuric acid. We now can go back to our sequence of reactions and work out the number of moles of reactant we needed if we assumed 100% efficiency. So our first set of mole ratios told us that if we started with 1 mole of sulfuric acid, we were going to need 1 mole of sulfur. In this question, we had 2 moles of sulfuric acid, so we are going to need to start with 2 moles of sulfur, but that's assuming 100% efficiency. Okay, so we have 2 moles of sulfuric acid. Now we need to work backwards using our efficiencies to work out the moles of sulfur. So when we were going forward, we were multiplying by the efficiency, which was 100 over 100, 80 over 100, and 20 over 100. Now, because we're going backwards, if I need 2 moles of sulfuric acid, and this equation is only 20% efficient, that means I'm going to need to start with a lot more reactant to make my 2 moles of product. So, working backwards, my number of moles of sulfuric acid is my number of moles of sulfur times the inverse of my efficiency. So if we're going forwards, we just go 20 over 100. Because we're going backwards, we use 100 over 20. So my number of moles of sulfuric acid is going to equal 100 over 20. Because this original number was 2, I have 10 moles of sulfur trioxide. So now I look at my second step. My sulfur trioxide is now going to be going back to sulfur dioxide with an 80% efficiency. So my number of moles of sulfur dioxide is going to be my number of moles of sulfur dioxide is my number of moles of sulfur trioxide times the inverse of my efficiency because I'm going backwards. So it's 100 over 80, so I need 12.5 moles. The last step is 100% efficient, so I would multiply by 100 over 100, so I end up with the same number. So to make 2 moles of sulfuric acid, I need to start with 12.5. And then if you think about it, 12.5 times 100%, I make 12.5. 12.5 times 80%, I make 10 moles of sulfur trioxide. And then 10 moles of sulfur trioxide at 20% efficiency, I end up making 2 moles of sulfuric acid, which I can now convert into a mass. So finally, change your moles of reactant, which is now 12.5, into a mass. Because we had 12.5 times the mass of sulfur, which is 32.1, I needed to start with 401 grams of sulfur to make that mass of sulfuric acid that was in the question. Okay, so I've quickly gone through these. Here is an example for you to try for yourselves. we have the sequence of equations. Your first job is to use that sequence of equations to find out the mole ratio. So you need to balance these equations and write your mole relationship, and then you need to try the two question types, which is to work out how much product you're going to make, and the second type where you're going to need to know how much reactant you're going to make. So if you can try and stop and do these, if you can't, go back and have a look at the previous examples, and on the next page next two pages I have the answers. So having a go at this, after balancing your equations and writing your mole relationship between the reactant in the first three reactions and the product of the final reaction, we end up with this mole ratio. First step, work out your number of moles of phosphorus. Second step, work out your number of moles of product, calcium phosphate. If we assumed we had 100%, we would then make 16,145 moles. Now multiply that number of moles by the efficiencies of your three different reactions and turn those moles into a product, and you should have got 3.23 tons, or 3.23 times 10 to the 6 grams. With the second reaction, we're going from oxygen, or we're going from calcium phosphate back to oxygen. So the mole ratio between the calcium phosphate and the oxygen, for 2 moles of this, I would make 5 moles of oxygen. So step 1, turn my moles of product, turn my mass of product into moles. Second step, work out how many moles of oxygen you're going to make at 100% efficiency, and then multiply by my efficiencies, which gives me 12,000 moles of oxygen being made, and then turn that into a mass. So if you have any questions with any of this, please come and see me.